right, we've done some permutations with restrictions and repetitions before, but not with this new notation. So I'd like to try that out. If there's a restriction placed on it, you have to deal with the restriction first. And sometimes it's just easier to use first principles, or sorry, the fundamental counting principle. So a reminder that when a permutation has a restriction placed on it, deal with the restriction first. Here we have the word logarithm. 1, 2, 3, 4, 5, 6, 7, 8, 9 words. 9 letters, sorry. So if there's no restrictions at all, then that's just 9 factorial. If the first letter must be an M, then that would be 1 factorial for the first letter, and then 8 factorial. If the first and last letters must be vowels, then we just need to go through and count up how many vowels. We've got 3 vowels, so we've got to have 3 vowels for our first choice. So 3 factorial ways to do that, or 3 ways to do that. And then the last letter has to be a vowel. So there'd be 2 ways to do that. And then that leaves 7 letters left. So 7 factorial. So we could say this is 3 factorial, 7 factorial, just by looking at the 3 times 2. All right, first 2 letters must be LO in any order. Now I have a strategy for doing this, and I want you to see how I do it. I'm going to revert to fundamental counting principle for this. And I'm going to say that the first 2 letters have to be LO in any order. So we have LO, so there's 2 ways to do it, and then 1 way to do it. And then 1, 2, 3, 4, 5, 6, 7, and 7, 6, 5, 4, 3, 2, 1. Okay, so you can see 2 times 7 factorial as our answer. All right. I'll develop that one a little bit further on with GAR. You'll see those examples. So the vowels must be together and the consonants must be together. So we said that there were 3 vowels. So we can have 3 vowels and they have to all be jammed together. So that could be 3, 5, 3, 2, 1. And then the rest of the letters. So that'd be 6, 5, 4, 3, 2, 1, or they could be in the opposite orientation. So we could have the consonants first, 6, 5, 4, 3, 2, 1, and then the vowels second, so 3, 2, 1. So I've got 3 factorial, 6 factorial, plus 6 factorial, 3 factorial, and that's the same as 2 times 6 factorial, 3 factorial. Okay, the letters G, A, R must be together in that order. So here's what I'd like to do. I'd like to imagine G, A, R over here, kind of like a package. And then what I'm going to do is I'm going to take all the other letters left, so there's 6 of them. 1, 2, 3, 4, 5, 6, and of course 6, 5, 4, 3, 2, 1 is the number of ways to arrange that. And then I want you to imagine that there's different places that I could stuff this GAR package, the GAR. I could put it here in the front. That's one way. 2, 3, or it could go in here. 4, 5, 6, or 7 different places that GAR could go. So we've got times 7 ways to do this. So we've got 7 times 6 factorial. Or if you want to write that as 7 factorial, you can. Okay. In that order, that's kind of a neat one, because if we were to allow that package to be arranged, then we'd be multiplying by the number of ways that we could arrange that as well. All right, there's our answer. The letters G, A, R must not all be together. Oh my goodness, this is a lot of different ways. Here's what I'm going to suggest. Sometimes the thing we want is easier to find by taking the total and subtracting what we don't want. So the wanted is the same as the total minus the unwanted. Now, we've got some of these things all together. The thing that we don't want is we don't want GAR together. I'm going to add in that order. No, I'm not together. Yeah, I'm going to add in that order. Okay, so the total number of ways we've got from 1a, that's 9 factorial, and then we're going to take away from that the number of ways that GAR are together in that order, and then that will be the total number of ways. So 7 factorial is what we ended up with up there. So 9 factorial minus 7 factorial is our answer. Okay, here's the next one. Is what we ended up with up there. So 9 factorial minus 7 factorial is our answer.